One agent can do a lot. But sometimes the right answer isn't a smarter single agent, it's splitting the work across multiple specialized agents, each with its own job, its own tools, its own personality. That's a multi-agent system. Today, we'll cover when to use one, the 3 coordination patterns that actually work in production, and a reality check on when one big agent is still the better choice. First, why split the work in the first place? Single agents struggle with 3 specific things. Conflicting roles. When you ask one agent to be both creative and careful, write something interesting but never make a factual mistake, quality drops on both axes. The agent compromises in confusing ways. Context overload. Stuff one giant agent with 20 different tools and a 1,000-line system prompt covering 10 different domains, and watch it pick the wrong tool. The model has too many options and not enough specialization. Sequential bottleneck. One agent does steps in order: research, then write, then edit, then publish. Multiple agents can do the research and the writing in parallel, then have one stitch the results together. When you hit any of these, multi-agent is worth considering. The mental model is straightforward. Think of your AI system as a small team. There's a project lead, we call this the orchestrator. The orchestrator reads the user's goal, breaks it into subtasks, and assigns each subtask to a worker. The workers are specialists. A researcher who's good at finding information. A writer who's good at composing prose. A reviewer who's good at catching errors. Each worker has its own narrow role and its own focused prompt. The orchestrator collects results, decides whether the goal is met, and either delegates more work or returns the final answer. Most multi-agent systems are some flavor of this team metaphor. 3 coordination patterns. Pick one, don't invent your own. Pattern 1, orchestrator and workers. The most flexible pattern. The lead agent splits a complex goal into smaller tasks, hands each task to a specialist, and assembles the results. Use this when subtasks are genuinely different in kind. Researching, writing, and reviewing are different skills. Pattern 2, sequential pipeline. The output of one agent is the input of the next. Like an assembly line. The researcher's notes feed the writer. The writer's draft feeds the editor. Each stage is focused, each prompt is simple, each agent only sees what it needs. Sequential pipelines are great when steps must happen in order and each step refines the previous one's output. Pattern 3, debate and consensus. 2 or more agents argue different positions on the same question. A judge agent reads the arguments and picks the best answer. It's slower and more expensive than a single agent. But it catches blind spots that a lone agent would miss. Used selectively for high-stakes decisions, debate is one of the most reliable quality boosts available. How do agents talk to each other? Through messages, usually structured JSON. The orchestrator passes goals, deadlines, and the schema it expects back. The worker returns a structured result, not free-form chat, but a predictable shape that the orchestrator's code can parse and reason about. Treat the boundary between agents like an API contract. Validate inputs and outputs. Log every message so you can debug later. The discipline you'd apply to microservice communication applies to agent communication. Now, a reality check. Multi-agent isn't always the answer. There are real costs. Costs multiply. 3 agents doing one task each call the LLM 3 times more often. If a single agent version costs you 10 cents per request, the 3-agent version costs 30. Token bills explode at scale. Latency grows. Sequential pipelines wait for each step to finish before the next begins. Users notice multi-second hangs much faster than they notice slightly worse quality. Debugging gets harder. When the output is wrong, which agent broke? Was it the researcher's facts? The writer's interpretation? The editor's polish? You need much better logging and tracing to even diagnose multi-agent failures. So here's the rule. Try a single, well-prompted agent first. Iterate on its prompt. Add tools. Add memory. If a